Hi everyone, subsection 3, other derivatives. Part 1, implicit differentiation. Alright, up until now, all of our functions have been f of x equals or y equals, that kind of thing. However, not all relations can be written in function notation or in y equal form. Some you can rearrange, some it works out really nasty, and others you just can't do it. So we can work with these things using something called implicit differentiation and using the chain rule. Okay, so for instance, if we have a relation such as a circle with a radius 3, so that's this equation here, okay, even though y is not explicitly stated as a function of x, it's implied that x and y are related somehow. To use implicit differentiation, all we have to do is take the derivative of both sides with respect to x. That's kind of one of those fundamental math rules. Whatever you do to one side, you got to do to the other. So let's consider this function, y equals 2x. When we take the derivative of this, okay, we get y prime equals 2. Okay, that you guys have been doing now for a little while, and it's pretty straightforward, not a problem. Okay, awesome. Now, the trick, though, is it's important for you to understand what is happening now that you know the chain rule. Part of this is so basic, I'm going to read right here, so basic that we ignore it almost all the time. The other part is super important, and it talks about or deals with how we get the y prime out of this equation. Okay, so let's try differentiating that really easy one from up top. Okay, so the first thing we're going to do is we're going to think of this as y in brackets, y to the 1, and then we're going to go 2, and then we're going to put the x in brackets to the 1. Okay, so if we use the idea of chain rule, the 1 jumps down in front, so 1y, and then decreases by 1, so 1y to the 0, and then we have to take the derivative of the inside, which was just y prime. Okay, we're going to do that same thing here, so 1 times 2, okay, so that's 2, okay, x to the 0, and then x prime. Okay, so write the derivative of x is x prime. Now, here, y to the 0 is just 1, so this is 1 times y prime. Okay, so the derivative of y. This one is 2 times 1. Now, what is this x prime thing? Now, when we differentiate a function that has x's in it with respect to x, okay, it actually works better in Leibniz notation. It's dx dx, right? The derivative of y was dy dx, right? Okay, but dx dx, well, guys, this is just like a fraction. Anything divided by itself is just 1. So this x prime thing is just 1. Like, again, this part is so basic that we ignore the x prime almost all the time, except for like right now. But we're going to keep on ignoring it from now on, so whatever. Okay, but the thing is, it's still there. Okay, I'll just erase those. Okay, there we go. Okay, so the x prime is still there, it's just we ignore it. The y prime, though, is super important. So really, we get the y prime equals 2 times 1, which is just 2, which is what we got when we did it the really easy way. Okay. Now let's apply that to something a little harder. Okay, so the derivative of 2 is just 0. We're going to take that 2 in front of the y. He's going to pop down, so 2y to the 1. We won't bother writing the 1. And then we have to take the derivative of the y. So the 2 comes down, so 2y to the 1, y prime. Okay? Plus 28x. We're not even going to bother with the x prime. Don't worry about it. It's just 1, so we ignore. Okay? It's the y prime that's important. So now we have to rearrange for y prime. All right, well, let's see. The 28 will just come over. So we're going to get 2y prime equals negative 28x. So then divide by 2y, and y prime equals negative 14x over y. So the fundamental difference here is that our derivative, our y prime, will have not only an x value in the formula, but it will also have a y value in the formula now. Not a big deal, it's all good. So let's try some examples. Okay, so example 1, differentiate y squared equals x. Okay, well, the 2 just pops down, so 2y, and then 2y to the 1, and then we have to differentiate the y part, so that's like the chain rule part. So 2y to the 1, y prime. See, if you put y to the 1 there, it kind of looks like a prime, so we've got to do that. It's kind of why we don't do it. So really we would write 2y, y prime, okay, equals, and the derivative of just x is 1. Okay, well we want the y prime, so we divide by 2y, divide by 2y, and y prime equals 1 over 2y. Ta-da! That's it. Okay, let's have a look at number 2, because these, they look really nice right now, but they will get challenging, so we'll just take it slow, one at a time, and go from there. Please feel free to watch these again as you need, because further along you will probably need. Alright, so we're going to find dy dx. Now, remember that's just y prime, so it's easier to put the y prime in the middle part, and we'll substitute out dy dx later if we really want. Okay, so we just differentiate, so that 3 pops down, so that's going to be 6x squared plus 2y, y prime, minus 4x. Okay, again, let's just hash out that y prime one more time because I know you guys are thinking it. Okay, so we put that in brackets. The 2 comes down, so 2y, okay, to the 1. And then we have to differentiate the middle part, or the part in the bracket, so that is the y prime. Okay, again, the y to the 1 and the prime because kind of confuse things. So 2y, y prime. All right, and you'll notice sometimes I write, sometimes I print, sorry. Okay, anyways, so that part's that. So let's erase this. Okay, 2y, y prime, minus 4x, and of course the derivative of 0 is just 0. So now we rearrange to solve for y prime. So let's see, the 4x has to come across, the 6x squared comes across. So 2y, y prime equals negative 6x squared plus 4x, right? Because it goes across the equal sign, it becomes positive. Okay, and now we just divide by 2y, divide by 2y. So y prime equals, now, before we just blindly go and divide, remember that 2 divides nicely into both of those. So this is going to be negative 3x squared plus 2x over 1y. Okay, this is the 2 divided out. Okay, so there we have that derivative. Okay, perfect. All right, let's look at this next one. What happens when you have more than one y in the equation? All right. Oh, sorry, way back up here still. Remember, it's dy dx, so we could just say that this is dy dx. It's the same as y prime, so all good. Okay, so determine dy dx for this. Okay, so this one's going to be a little longer, and sorry I didn't leave myself a lot of space with the notes. Okay, so I'm just going to come up here. So this is 4y cubed y prime plus 3y squared y prime equals 5x to the 4th plus 1. Okay, now this is just an exercise in factoring. See how both of these terms have y prime in them? And I'm leading you up to this. Like eventually we're going to have to get all the y primes on the same side. But for now, they just are on the same side. Okay, so the y prime factors out. And you get 4y cubed plus 3y squared equals 5x to the fourth plus 1. So now we just divide. Okay? 4y cubed plus 3y squared, 4y cubed plus 3y squared. And so then y prime equals 5x to the fourth plus 1 divided by 4y cubed plus 3y squared. And that is our derivative. Hooray! All right, so not crazy evil, but certainly getting there. All right, so number 4, let's have a look at this guy here. Okay, so determine y prime for all of this. Now, this is starting to get nasty. Look at this, 3x squared times y. Guys, that is a product, which means we have to do product rule, yay! All right, so product rule, remember, said the first function, and yes, right over here, we're going to need some space, the first function times the derivative of the second function. Well, what's the derivative of y, guys? Just y prime. Plus the second function, y, times the derivative of the first. So that's times 6x. Okay, derivative of the, first times derivative of the second, plus second times the derivative of the first. So that's the product rule. Okay, and then we have, oh look, derivative of 3y is just 3. Okay, and then 3y prime. Now let's expand that a little bit. 3y, okay, so that's 3y to the 1. Okay, so 3 times 1 is 3, y to the 0, and then the derivative of the y is just y prime. So 3 times 1 times y prime, that's why it's just 3y prime. Okay, equals 12x squared. Now remember, technically there's an x prime there, but we ignore it. Bye-bye, see ya. All right, so now we have this. Now we have to get all the y prime terms on one side and all the other terms on the other side. So this is a y prime term, that's a y prime term. So 3x squared y prime plus 3y prime. We're going to move this part across. So equals 12x squared minus, and I'm going to rearrange that to 6xy. Right, this part here is just 6xy. Okay, awesome. So now my y primes are on the one side. We did this a lot with logs in Math 30-1. So anyways, y prime 3x squared plus 3 equals 12x squared minus 6xy. And then we divide. 3x squared plus 3, 3x squared plus 3. Now it is kind of important to note that everything has a common factor of 3 here. Okay, so we can take that out. There's an x in 3 of the 4 terms, but in order to take an x out, we have to have x in all 4 terms, so that just doesn't work. But there's a 3, or a factor of 3 in all of them. So y prime equals, so we're going to divide everything by 3. So 12 divided by 3 is 4x squared. 6 divided by 3 is minus 2xy. 3x squared divided by 3 is just x squared. And 3 divided by 3 is just plus 1. So that is as best as we can do there. Now, it's starting to get a little more complicated, but that's all right. Okay, so number 5, determine dy dx if we have this. Okay, as soon as we see that, oh look, that one's a product again. So that's going to be first. Okay, it's first function, so 3x times the derivative of the second, so y prime, plus the second function, so y times the derivative of the first. So the derivative of 3x is just 3. Okay, then minus 3x squared equals 3y squared y prime. Okay, and the derivative of 6 is just 0, so we don't even bother putting it. So you'll notice now that the y primes, there's two of them, but they're on different sides. So we're going to take this guy and move him over. So, and then we'll do some rearranging as well. So this y3 is just 3y minus 3x squared equals 3y squared y prime minus 3y or 3x y prime, right? Because when that goes across, it becomes negative, sure. Okay, then we factor out the y prime, 3y squared minus 3x. Okay, it looks good. Okay, 3y minus 3x squared, so we divide now. Okay, and you will notice that again there's a common factor of 3. Not everything has an x and not everything has a y, so we can't simplify the y's at all. Okay, so y prime, but we are going to divide by the 3. Here, let's try something different. We'll just factor the 3 out, so y minus x squared over 3 y squared minus x. And then the 3's cancel, so you can kind of see how that division thing works. And remember, it did specifically ask for dy dx, so I guess we should do that. So dy dx, which remember is the same as y prime, equals y minus x squared over y squared minus x. So there you have that. All right, number 6. 6 is a little weird. Okay, it says find the equation of both tangent lines to the circle that at x equals 2. So I know that conic sections isn't in Math 30 anymore, but we're still gonna, this is a circle. Okay, and then the equation of a circle, guys, is x squared plus y squared equals r squared. So this is a circle, so what squared is 9? Well, that's 3 squared. So really, this is a circle with a radius of 3. So 1, 2, 3, 1, 2, 3. So centered at 0, 0 with a radius of 3. Okay, so that kind of looks like, woo, yay, nice little circle. Awesome. Okay, not the greatest circle, but whatever. Okay, so we want when x is 2. So when x is 2, we're about there. When x is 2, okay, that is definitely like there-ish. Okay, so we want these equations of the tangent lines. That's what we're looking for. Okay, so anyways, not a big deal. We'll figure it out. All right, first things first, remember the derivative, the y prime is the slope. So we're going to take the derivative of this function right off the bat. Okay, so this is going to be 2x plus 2y y prime. Remember, it is 2x x prime, but the x prime just equals 1, so don't worry about it. Okay, I keep moving the screen here. Sorry, guys. Okay, and the derivative of 9 is 0. Okay, so my y prime, I guess I should do that more. So 2y y prime, we're going to move the x over, equals negative 2x. Okay, so divide by 2y, divide by 2y. So y prime equals, okay, the 2's cancel, so negative x over y. So there's my slope. So the slope of the tangent line is that. Okay, oh, wait a sec though. Remember, it's not good. Like before, it was good enough because all our slope equations just had x's. But now our slope equation has y's, so we kind of need to solve for the y values. So let's go over here. So when x is 2, so we get 2 squared plus y squared equals 9. Well, 2 squared is 4, so 4 plus y squared equals 9. Minus 4, so y squared equals 5. So y equals plus or minus square root of 5. Okay, and just for the fun of it, let's type that in. Okay, so square root of 5. So that's like 2.23-ish. Does that make sense? Like, so 2 and a little bit, and negative 2 and a little bit. Yeah, it's 2.23, sure. Okay, not that we're going to use the 2.23, but it does help to, okay, well, that's kind of what that is. And again, plus or minus. Okay, so here's the thing. We've got 2 points on this circle when x is 2. We've got the point 2 and positive root 5. And we've got the point 2 and negative root 5. Okay, so we're going to have separate slope, separate equations for each of these. So, tell you what, let's figure out the slope for this guy. So the slope, which is the y prime, which is negative x, so negative 2 over positive root 5. Remember, we can't leave it like that. We have to rationalize. So negative 2 root 5 over 5. So that's the slope. So the equation then is going to be y minus root 5 equals the slope, so negative 2 root 5 over 5, x minus 2. So there's your one tangent line. That's this guy up here with the negative slope. Well, also that point would be positive 2, positive root 5. Okay, you know what, I'll write in red for this one. Okay, so then for the other guy, the slope is y prime equals, okay, so negative x, so negative 2 over y, which is negative root 5, okay, which is equal to positive 2 root 5 over 5. So that's the slope of that one. So this now is y plus root 5 equals 2 root 5 over 5, x minus 2 again. You'll notice that there is a positive slope. That is this tangent line. Positive slope going through 2 and negative root 5. Okay, kind of neat. So those are the tangent lines. So that, okay. Last one. Find the slope of the tangent lines to the graph this when x equals 1. Wow. Okay. Tell you what, guys, there's a few ways we can do this. So for this one, I am going to choose just to work with this as is. Not going to be a problem. Okay, so I'm going to take the derivative as this function right now. The alternative is to get rid of the fractions first, right? And we do that by timesing everything by the lowest common denominator, which would be 36. So if we timesed all that by 36, we could do this without fractions, but it's really not a big deal. Okay, so I'm going to do this as is. So the derivative of 2x is just, x squared is just 2x, so 2x over 9 plus 2y prime over 4 equals 0. Okay, derivative of 1 is 0. Okay, awesome. Okay, so this fraction is just going to go over, so 2y prime over 4 equals negative 2x over 9. Right, when that moves over, it becomes negative. Okay, to solve these now, we just cross multiply. So this would be 18y prime equals negative 8x. Okay, again, solving for y prime, divide by 18y, divide by 18y, and y prime equals, okay, well, there's a common factor of 2 here, so negative 4x over 9y. Okay, there is our derivative. Okay, awesome. So that's going to be the slope of the tangent lines. Okay, now the slope when x equals 1, remember this slope has a y in it, so having x equals 1 isn't good enough anymore. Okay, so we need to find the points. So when x is 1, we get 1 squared over 9 plus y squared over 4 equals 1. Okay, well, let's see. 1 squared over 9, well, that's just 1/9. Okay, plus y squared over 4 equals 1, so minus 1/9, minus 1/9. Well, guys, 1 minus 1/9 is 8/9, right? So y squared over 4 equals 8 over 9. Okay, so then that 4 multiplies up, so you get y squared equals 32 over 9, and then we have to square root. So y equals plus or minus square root of 32 over 9. Okay, well, we can separate that square root, so square root 32. And what is the square root of 9? Well, square root of 9 is just 3. Now, I know what you're thinking. This is getting kind of messy, but that's okay. Root 32, I'm going to go back down here because I'm running out of room. Okay, root 32 reduces. Okay, 32 is 16 times 2. So the 16 kicks out a 4. So 4 root 2 over 3. So that's the y value there. Okay, so now, of course, we need the slopes. Okay, so those are the y values. So I guess technically, the y value would be 4 root 2 over 3, or negative 4 root 2 over 3, right? Because there's the positive and the negative version. Here, I've got a little more room now. Okay, so the slopes then, so that's the y prime. So negative 4x. Okay, well, remember x is 1. So negative 4 times 1 divided by negative 4 root 2 over 3. Okay, well, hey, look, guys, the negatives are going to cancel. The negative 4s actually are going to cancel. Okay. So we're going to get 1 over 2 root 3. Remember, how do we divide fractions? We flip and multiply, so times 3 over root 2. So, okay, 1 times 3 over root 2, so that's going to be 3 over root 2. Can't leave it like that. 3 root 2 over 2. So that is the one slope. Okay, that's when we had the used this point, that y value. Okay, so y prime, which slope was 3 root 2 over 2. Okay, now let's try the other one. Okay, so y prime would be negative 4 times 1 over, so now we're using the positive 4 root 2 over 3. Okay, again, the 4s cancel, not the negatives this time, just the 4s. Okay, so that's going to be negative 1 over root 2 over 3. So flip and multiply, so that's going to equal negative 1, so negative 3, over root 2. Okay, which is going to be negative 3 root 2 over 2. Okay, now, last question, it said to figure out the equations of the tangent lines. This one just wants the slopes. Okay, I'm going to find the slopes when x equals 1. So when x is 1, there is this guy here or that guy there. So we have one slope that way, one slope this way, one's positive, one's negative. Okay, and we have our 2 slopes. Okay, we don't need to go any further with the equations or anything. And yeah, so guys, that's this section. Please feel free to rewind, go over it again. The most important part here, remember, is just when you have a function, let's say 2y squared, okay, the 2 comes down, so you get 4y to the 1, but then you have to chain rule the y, and that's where the y prime comes from.